Well, I've been working with ECLSS pretty much since the beginning of my career back in 1985. Back then, space station was in Phase B, and we were young engineers playing in the lab with the first life support systems, trying to figure out what we could use, what would work. And so fast forward, now we've got a working regenerative life support system on the space station. It supports 6 crew. It completely recycles the air and the water for the space station crew. And we're working on how to further evolve that and improve upon it so that we can take it beyond low Earth orbit. ECLSS is made up of a lot of different functions. We have to condition the air, temperature and humidity control like your air conditioner. Like on Earth, we have plants to remove carbon dioxide and give us oxygen. Well, we don't have that in a closed environment like space stations, so we rely on chemical equipment to essentially remove the carbon dioxide and then replace it with oxygen for the crew to breathe. We remove contaminants from the air. In the water area, we have to manage all the crew's waste, including urine and sweat. Humidity out of the air is removed and recycled and turned into clean drinking water. And then we have to deal with solid waste as well. So we do the potties. We also have emergency equipment we're responsible for, fire detection and suppression, and then monitoring of the atmosphere and the water. We use iodine to control the microbial population in the product water. And we use a specially developed resin that imparts the iodine into the water. It's released from this resin. And that was licensed. It was developed for use initially for shuttle and became part of our water processor. And then that was sold to a company a commercial company who has turned it into ground-based filtration systems that they have taken across the globe for deployment in villages, for disaster relief, and all kinds of applications. So that's been really neat to see that application. We've got a working system on space station. We worked hard on that. We definitely want to start there and evolve that into what we need for future missions. But as we cut the umbilical from Earth right now, we have the ability to send supplies up. If an emergency happens, the crew can go home, back to Earth. We can send samples down. We won't have that for future long-duration missions. They're on their own. So we need our systems to be more reliable, not break down, and not have to carry a lot of spare parts, and then also not to have to resupply oxygen and water. So we need to actually recycle more, close the loop even more as we go further. So we're looking at ways to do that starting with our existing systems and make them less complex, therefore more reliable and more efficient.
Will we see a demonstration like that on space station
That is our goal. That is our goal. By the end of the space station life, we will have demonstrated the Mars ECLSS, on station, the system that we want to take for the future. And the space station is that perfect platform to do that.